the revolve shape for this guy. We'll have this down here, and then we'll have that. And that will be the green shape. And so we're going to have a series of disks. All of these red disks will have the same constant radius of 2. But then all of these blue ones will have a radius that's being defined by this curve 4 minus e to the x. And so if I ever have two different shapes or radiuses and it's not a subtraction problem, then I'm going to need two different integrals. I'm going to need the first part, which is essentially a constant cylinder. And the second one is this part that changes. Does that make sense, Jonathan?
Yeah, it does. Yeah.
And so that's why when we look at this next one, if we're to revolve it, we always have this same set of circular areas, all dependent on that distance x. Okay, as we look at the next one, because I revolve in this manner, even though there's a donut and I'm going to cut something out, still big R will always be defined by that upper curve, and little r will always be defined by this distance, probably of 1. But then, what's going on with this last guy, Nia? Talk us through the last one. You had this totally right. I'm pretty sure you know. Why do we need two integrals for the last one, Nia? Nia, are you with us?
Oh yeah, I forgot to unmute.
No problem.
Uh, yeah. So I saw that like there's a kind of like an imaginary flat line at the bottom. So I just saw that that was um two integrals.
So this integral here in blue, it's always going to have a big R of about 3, isn't it?
Yeah.
And a little r of, what's the little r going to be?
The little r is gonna be like e to the x.
I don't think so. For
Or
this first section, from like as we look below that red line, you see how the little r is always going to be from the axis of rotation
Mhm.
over to the y-axis. So that's going to always be 1 unit. But when we look at the part above, Shannon, what's going on when we look at the part above that red line? What kind of shapes do we have now?
You have like a weird, like sloped line that's concaving.
Uh-huh.
So you have what e to the x up there.
Yep. So like if I go from the axis of rotation over to that e to the x line, is that my big R or my little r?
Your big R.
Does everybody agree with that?
it would be little r, right? Because of the x equals 2, since it's like.
So you're saying maybe all the way over to the brown line to x equals 2 would be big R,
Yeah.
and the blue radius would be little r. Shannon, what do you think? Has Jonathan convinced you or not?
Yeah, I just couldn't see where the arrow was going.
Okay, fair enough. Um, I should blow up a little bit more, but anyway, so hopefully now we can see. Oh yeah, our little r is a little bit shorter than big R, But what I want you to see is there's two distinct big R's and little r's. If there are two different distinct big R's and little r's, that's when we'll need two integrals. So let's do this. Use what we have here. And let me go back to my Pear Deck a minute. Now try to actually write what you think those four integrals would be. It might take a few minutes, and that's okay. But try to work through them. We know we've got two integrals, then one, and then back to two. See if we can come up with what those two integral or those four different problems, what the integrals will be. I think it'll take us at least 2 minutes. Totally fine. Work at your own pace, but try to put your answers there on the slide. If you need more space, you can work above it or however you want. Looking good, Brittany. Ooh, actually, Brittany, think about your limits. If you're going to have two integrals, are they going to go all the way from 0 to 4 for that first one? Good. Sorry about that. Good start, Jonathan. That's totally right for that first guy. Stephen, again, think about your first limit. Do you see how you're going from 0 to 4? But we probably need two integrals, so we won't go all the way to 0 to 4 for the first integral. Same thing, Giovanna. You're adding the integrals, or you're subtracting them. But I think those two different integrals are going to be additive because we've got to pick up the two different pieces. Good, Nia. Good, Lynn. I like your limits. Keep going. Great, Manuel. Cesar, I like your first integral. Is that a 4 or an A? That's your first limit. If it's a 4, it shouldn't be. Your first upper limit of integration shouldn't be 4. What should it be? That's great, Adam. Keep going. Raul, I like what you have written, except those responses should be additive. Aaron, that looks good. And good. Your first integral is entirely right, Aaron. Great job. Keep going. Shannon, first one looks perfect. Except that I don't think that they necessarily meet at 2. Hasey, check your limits, Hasey, but otherwise you're looking good. Remember to use where they meet as A comma B. Shannon, that's perfect. Great job. Yeah, I like your limits. A couple other things are missing though. Anna, great job. Not only is your first one perfect, but it's really easy for me to read. Katie, great job. Jessica, great job. Keep going on a couple more. Anna, those pictures are amazing. Okay, check what you had, or try to remember what you had. I'm going to go back so you can kind of put what you had in your memory banks, and then we're going to look at the answer. So this should be able to show you what you had in your slides. Take a picture of them maybe, or just like block them in your brain. Maybe take 10 seconds to take a picture of your slide, because I know once we move past it, you won't be able to see it anymore. So take a picture of your slide. These were the answers. We're going to say that the first one is A, second one is B, third one is C, fourth one is D. If you had two choices, A, B, C, and D, on this slide, type in the two you'd want to look at. You can write or type. Your choices are A, B, C, D. You only get two choices. So 3, we can do that. 1, 2, 3, 4, 2, doesn't matter. We've got to vote for 3, it looks like. Give me 1, 2, 3, or 4, 2 of those max as we go across from left to right.
Do we write this in the chat? Or...
Just, well, I was thinking put it on the slide.
Oh, okay.
But you could put it in the chat too. Just put it in the chat. The chat will be easier. Or I love it. Somebody just circled one. Just circle it. That's perfect. Just circle the one or two you'd want to talk about. Lynn's made her choice. Manuel's made his choice. Yair's made his choice. Anna. Okay. Yup. It's really close between 3 and 4 and 2 and 4. Okay, 3 and 4 have it, but if I can, I may go over 2 as well. Okay. So go to a place where you can take really good notes. I think it's best to have it be in your notebook, because that way you can also watch my screen. We're going to look at number 4 first. And I'm just going to take my picture a minute. Over off to the side of the screen. Okay, so the first thing we need is a picture. We know that we have 1 unit in here, so I'm going to have another 1 unit in between where I start to revolve my new shape. And we said we needed two integrals. The reason is from that line right there below is one set of curves, and above is another set of curves. So my first integral, I just have a constant inner radius and a constant outer circle. So I will have, well, if this is x equals 2, and this is x equals -1, my big R is equal to 2 minus a -1 or 3. And my little r is equal to 0 minus a -1 or 1. And so that first integral will be pi times 3 squared minus 1 squared dy from 0 up to where e to the x hits the y-axis. That's going to be y equals 1. That would be the first part of the integral. Any questions on that? Again, this is the time, like when it gets hard like this, for you to be super selfish, and if you don't understand, we got to talk about it, and you got to say, hey, I don't get it. And I'm not looking at the chat currently, so try to unmute if you have a question. Okay, so that part is good, correct? Now, the next part, as we get above that red line into the blue portion, I need to go to the black curve for my little r and all the way to the brown line for my big R. And so that means my big R is equal to that same 2 minus a -1 or 3. It's always 3 the whole time. But that little r is the tricky part. How far is it? Well, it's whatever this x coordinate is. So my little r will be whatever that x coordinate is minus a -1, because I'm going to go from right minus left. And so I have to figure out what this x coordinate is. If y equals e to the x, then how can I figure out what x is? Go ahead, Jonathan.
You would do ln to both sides to cancel out the e.
Yeah, because I'm trying to get x by itself. So if I do ln to the entire thing, I will have ln of y equals ln of e to the x, but that just cancels each other out, and I'm really just left with x. Now, I'm not sure why there's a 4. Oh, I think I know what I did. I think when I made up the key, I was thinking that equation was 4 minus e to the x instead of e to the x. So that's going to slightly change around our answer. But nonetheless, that means my equation for little r will be the x I just came up with, ln of y, minus a -1 or +1. So my answer on the slide wasn't quite right. Should have been ln of y +1 is my little r. Jonathan, was that one thing you were wondering about?
What's that?
Were you wondering about that or not? Like it looks like what I had in the answer key on that slide wasn't quite right.
Yeah, I think you explained it well.
So my second integral would then go from 1 up to this y coordinate of b where they meet. So I'd be from 1 to b of, we said big R was 3, I'd have to square it, minus little r, we said was ln of y plus 1, I'd have to square that. Okay. And the other one folks wanted to look at was this number 3. I can already tell that portions of this answer won't be right, but let's really take a good look at our rotated shape.
Hey, mister, I have a question real quick.
Go ahead.
For that second integral for the last question, does it not have a pi at the beginning?
Oh, of course it has a pi at the beginning. I am super good at forgetting my pies. So make sure to make a big deal out of it, because if I at least can't be guilted into some embarrassment, because there's nobody here to mark me off when I make a mistake, and I'm going to mark you off on a quiz. So great job, Manuel. Mark me off when I screw up in my lessons. Let's take a look real quick at this guy. Super quick. If I'm revolving around that, let's see. Oh, I just did the same one. I don't want that one. We want this new picture. This actually might be right. This answer might be right. As I revolve around this axis here, we've got this same space above and below my axis of rotation. So this red figure with the yellow drawing inside, that is definitely my revolutions. And again, because it's always the same set of circles, we have one integral. This time we can go from 0 over to 2. And I'm going to have 2 different radii. This time the radius is going from my axis of rotation up to the upper curve. That would be my big R. And my little r will be from that same axis of rotation up to the bottom curve. So who can tell me what big R is and who can tell me what little r is? Stephen, do you want to take a crack at big R? E to the x.
Oh, is it plus 1?
It will be plus 1 because it's going to be minus a negative 1, isn't it? But we always could simplify that to making it plus. And then let's see, Jorge, what do you think little r is? Jorge, did you hear me call on you? Brittany, what do you think? Do you know what little r is?
I would say 0, subtract, or plus 1.
Either way, 0 subtract a negative 1 would work, wouldn't it? Which is the same as 0 plus 1, or we could just write 1. So let's see, Manuel, can you tell me what the entire integral would be?
I believe it's gonna be e to the x plus 1 minus 1
Just like that?
and then squared.
Squared like this?
Yeah.
Or each one individually?
Or actually each one individually.
Okay. You're totally right. dx or dy?
dy.
Everybody agree?
I think it's dx.
Why do you think this one's dx?
Oh, okay. Never mind.
You agree, Manuel?
Yeah.
Okay.
And then your pi at the front, mister.
Yeah. I was going to let you forget it this time, but you wouldn't because you're too good. That's how we would do 3. And again, I know it's going to take more practice, but every time we do one, I think we're going to be better and better. But I want us to go now to our building. I want us to build something. So I'm going to go to the content library. You can go there too, because this will be where you can see your directions if you want to see them. Even though we're not on 9.1, we're 9.2, I had it called that. What I want you to do is on your sheet of paper, draw what you see in black, blue, and red. And I'm going to kind of show you what I want you to draw. I want you to draw that picture. If you don't have graph paper, you can still draw it. You're just going to want to try to make nice, even tick marks. And it also shows on my screen what you should be drawing. Okay. As soon as you've got that drawing, I want you to cut 2 squares that look like my green squares, and I want you to tape them onto your base so that it's going to kind of look like what you see here. You see how I've got two of the same squares taped up above my piece of paper, perpendicular to the x-axis. Take a minute to do all that. Once you've got that part done, put your camera on for a minute and show me what you got. Any questions?
How big are the pieces that need to be cut out?
Okay, well, do you see how they have to go from the x-axis up to y equals 4?
Yeah.
So you can just take your piece of paper, put it down on your drawing, and measure it however long that is and cut it out. That's like, you don't even really need a ruler. You could measure it and then transfer it with a ruler, or you could just put a piece of paper down on your base and measure it that way. Does that make sense, Jonathan?
I think so.
Because everybody's drawing is going to be a little bit different. So depending on how, how big your distance between 4 and the x-axis is, that's what your first 2 squares will be.
Mr. Heffron,
Yeah.
my computer is requiring me to restarting, so I'm gonna end call and I will call you back.
Right. Yeah. Just jump in the call as soon as you're able to do that.
Okay, thank you.
And I'm going to take a minute while you guys are working to take roll. And if you get ahead, you can see the next piece we're going to do is we're going to do those blue squares, and you get to decide where the blue squares go. If they're close to the intersection or if they're smaller down, you can decide.
Mr. Heffron, how big are the cutouts supposed to be?
You'll have to talk louder, Stephen, because I just can't hear you.
How big do the cutouts have to be?
You get to decide because your picture is of all different sizes. But what I want you to see is that it has to go, those two squares, they have to go from the upper curve to the lower curve. So you measure that using either a ruler or just putting a paper down and extending it from the upper curve to the lower curve and make a square. Because it has to go all the way from y equals 4 down to the x-axis. That part's for sure. Jerry, are you with us? You weren't earlier. Are you with us now? Stephen, did that help? Now what I want everybody to do is to draw and make the next two squares. And you can sort of see I'm trying to show that here. I'm going to stop sharing my screen so this looks bigger to you. Now, hopefully you can see this even bigger, but it looks like this. I've got two squares that are the exact same on the left side of my construction. And then this next set of squares start to get smaller and smaller and smaller. I made 3, you only have to make 2. Take a picture and put your work in. I'm gonna send this out to your student page. I want you to put a picture of your work in the student page. So give me just a second to get this out to you.
Student page is the one that has our name on it, right?
Yeah, but I don't think this is in there yet. But it should just be showing up on your computers now. You can take a picture of your work and put it in your student page, and then you can write underneath it, hey, what would the volume be if we have a set of squares that are all the same dimensions until the red and the blue curve intersect, and then the side length of the square start to get smaller and smaller and smaller. How many integrals would we need? And what would that volume be? Casey, how is your construction coming? How is your solid?
I'm cutting the little squares out.
Perfect. Yep, and you got to tape them, and it's a little like you only need 2 of them. So don't try to make 3 or 4. Just do 2 in each spot. The bigger your squares, the easier they'll be to tape down. That I learned.
Yes.
So I'm going to put in the chat here. I'm done with my construction, or not. Done with my solid. When you're done, please put a thumb up on that. And what I'm doing now, if anybody is ahead, I'm starting to build my other solid. You don't need to build your other solid right now. You can build it later. But if you get to it now, great. When I say the other solid, I mean the other direction, when we have our squares go from the y-axis over to the curve.
So we take a picture of it right now, like once we're done.
I tell you what, why don't you wait, because I'm going to have you do the other one too, and we'll do them all. Like, you'll just take a picture of both and submit them at the same time. Does that make sense?
Yeah. Is it all right if like your
If you've already done it, it's fine. Like, yeah, if you've already done it, go ahead and submit it, but I'll have you submit one more that goes the other direction.
Okay. And is it all right if like your pieces of paper don't like stand up very well on the tape?
It is okay. What I did to get them to stand up is I taped them on both sides. So if you tape it on one side and then the other, I think they'll stand up a little bit better. You can try that and see if you agree. You kind of have to hold them and push them back up. I'm going to put this back on my screen a minute. Can you guys see the two different ones that I've built? Is my camera showing up pretty well? It's hard for me to see what you're seeing.
Can you put the model a little bit higher?
Like that? Is that better?
Yeah.
Yeah.
So what you can see is my upper drawing has the rectangles perpendicular to the x-axis, or the squares, and my lower drawing has the squares perpendicular to the y-axis. And so here's my question to you. Which one needs two integrals, the upper drawing or the lower drawing, or solid really, and why? Don't shout it out. I'm gonna take volunteers and/or cold call some people, but formulate your answer. As you're looking at my picture, perpendicular to the x-axis is the upper, perpendicular to the y-axis is the lower. Which one needs two integrals and which one needs one? Go ahead, Anna. I saw your hand up.
So the one with them perpendicular to the x-axis would need two integrals?
Tell me why. You're absolutely right.
Mostly because the sizes are like varying between, what is it, x equals 0 to x equals 4 and 4 equals, and between 4 to 8.
So does it vary from x equals 0 to x equals 4, or is it always constant?
It's constant from there, and then it's constant between 4 and 8, but it's different sizes between both areas. I don't know if I'm making sense.
I think you are. I mean, basically what I'm hearing you say is we have the same the same square always from 0 to 4. So that would need its own integral. Then we have a different set of squares from 4 to 8. So we would need an integral to figure that out. Is that what I'm hearing you say, Anna?
Yeah.
Okay, that's perfect. I love it. I want to hear from Giovanna. Giovanna, why do we only need one integral for the squares perpendicular to the y-axis?
Because to the ones perpendicular to the x-axis.
No, to the ones perpendicular to the y. So the bottom picture of the two. Anna's saying the upper picture needs two integrals. So this bottom one must only need one. Is she right? And if so, why?
To be honest, I'm confused right now, mister.
Okay.
But I see why we need the two integrals.
For the upper one?
Yeah.
Okay. So for the lower one, we are always going from the line y equals 8 minus x over to the y-axis. Agreed?
Yeah.
And so that distance changes, but it's always changing between those two lines. Whereas the upper graph, the thing that defines what the side of the square is depends on whether you're going between 4 in the x-axis or if you're going between 8 minus x in the x-axis. There's two different upper curves for the upper solid. There's only one right and one left curve for the bottom solid. And that's how we know. If the upper and lower curve or the right and left curve change, you'll need two integrals. If they don't change, you'll only need one. Okay, now I'm going to go back to a screen share so that we can write some of this down.
Mister, did you make the tab to put our pictures in?
I think so. Does it not show up?
For me, it does not. Or never mind. I think I see it now.
Good. Sometimes it takes a little while to get there. So let me just try to get the right view here. Just once. I wish this was easier. Okay. So if you look at my screen, I have two different integrals for the first solid you built. Just like Anna said, we're going from 0 to 4. For this first set of green rectangles. And our second integral is for the blue portion of the graph I'm highlighting, where we have blue squares. And those blue squares, their height is always changing because the upper curve is always changing. Does that make sense to you, Manuel?
Yeah.
And so now I want to look down at the one below. We always just have an x value on the right and an x value on the left. There's never a second set of curves besides the right side and the left side. And so that means in this case, our volume will equal the integral from 0 up to 4, because now we're slicing the other direction. dy is our thickness of our paper. And we want an x on the right minus an x on the left. My question to everyone is, what is the x on the right? And what is the x on the left from the graph that you have? Anna, I'm going to come back to you. What graph is on the right? Is it the y equals 8 minus x, or is it the y-axis? Katie, do you want to answer this? I see your hand up.
Wait, isn't?
If you guys think about the solid you built, you measured your rectangle when you make it. If you haven't made it yet, when you measure it, you're going to go from this blue line over to the y-axis. This will be one of the sides of your first square. Another one would be up here. A different length, so I'll give it 2 tick marks. But in each case, it's going to be x minus x. I hope you see that the x on the left is always 0 because that's the y-axis. So this in this case will be 0. The right one will be if I solve this equation for x. And when I do, I will have x equals 8 minus y. So that's my x on the right. My x on the left is 0. Because I have a square, the area of a square is equal to side times side, or side squared. So I'll need to take this distance, this is just a side here, and I'll square that. And so my volume in this case will be the integral from 0 to 4 going up and down now, 8 minus y squared dy. This time I only needed one integral. Can you articulate any questions?
Mr. Are we supposed to also make another, like one of these drawings for this one?
So yeah, what ultimately your goal will be, I'll try to hold mine up again, but you're going to try to have 2 of these. One that's perpendicular to the x-axis like we all had time for. Part of your homework will be to build the other one perpendicular to the y-axis like I've tried to draw. And then I'll just have a couple practice problems for you to do to practice the calculus side. Okay. But in building them, I'm hoping that like in building these, that will help you be able to visualize these better going forward. Does that make sense?
Yeah, it does.
Because some of the hardest part is just visualizing what you've done. So I want to look at the guided practice here real quick. Region R is the base of the solid in the XY plane. A volume is formed by semicircles with the diameter drawn from f of x to the x-axis perpendicular to the x-axis. Find the volume as an integral expression. So if we think of that green area as the bottom of a paper, like a flat paper, I have a semicircle with diameters that go from the upper curve to the x-axis. There's one semicircle. A smaller one would be here. My question to you is, what's a good expression for volume? And will there be one or two? Let's start with that question. Jorge, I came to you once and you weren't there. Are you there now, Jorge?
Yeah, I am now.
Awesome. Is this going to be one integral or two?
I think one.
I think you're right. I think you're absolutely right. Do you know the limits of integration, Aaron? Or Lynn or anybody, like just jump in. Let's see if we can get this out before our time goes. Go ahead, Mia.
0 to 1.
0 to 1. And then what would go inside the integral? What is my area?
Pi r squared
I love it.
divided by 2.
Is pi r squared divided by 2. So that's going to go in here. I'm going to leave r as parentheses for now because I need to decide what r is based on my shape. Katie, can you tell me, do you know what r is going to be?
Oh, I think r gonna be x squared plus 1 minus 0 and then square on of that.
Does everybody agree with Katie?
Yeah.
I don't. She's really close though. Does anybody see her error?
I think it's because we're not finding the radius.
Yeah, we need to find the radius, but isn't that distance that Katie gave, x squared plus 1 minus 0, isn't that the diameter?
Oh, you have to divide by 2.
You do. You have to take what Katie said, x squared plus 1, and you have to divide it by 2. And then we would have dx. So that is one example of how this looks. I haven't sent out a homework yet because I didn't know how far we'd get. So I will send that out as soon as I have my next class, but you can bet it will be finish your solid. So you have perpendicular to the x, perpendicular to the y, take a picture of it, and then do a couple practice problems, not a lot. Okay? Clear as mud?
Yep.
Okay. We will practice more of this, and then we'll put it all together next week. Because it gets hard when, I can do each one of them, but when I have to put them all together, it makes my brain hurt. And practice, of course, is the key. One more thing that's important, office hours Thursday and Friday from 4 to 5. That's when I'll be doing it, unless there's not that many AB folks that come. If there's not, then I'll move it up. Okay.
What were the times again?
4 to 5 on Thursday and Friday, and Amy Wynn and Catherine Tran will be helping office hours. So if you want to see those guys again, come to office hours, you'll get to. Okay, you have to go. I have to go. I'm terrible. I let you out again late, but unmute and say goodbye to everybody.
Bye, Mr. Have fun.
And
Take care.
Bye, have
guys
fun.
tomorrow at school, because I'm going to be running my office hours from school so that I can be there for a senior drop-in. So I'll see you guys.
Wait, Heffron, I got one question.
Yes.
So the homework is just to take a picture of like both, right? So once you have the solids for the first image and the second one, right? So like this, and then
Right.
I just do the second one.
And I'm going to put 2 or 3 practice problems in there for you to do what we just did with this one.
Okay. All right, that's all I had. All right, thank you, Heffron.
You bet.
Take care.
Bye, guys.